Okay, these are the questions from the test at the end of the last term, the solutions. So in these questions, we're going to be using FOIL, which stands for first, outer, inner, and last. So the way we look at it, first, outer, inner, last. So when we do that expansion, we've got x squared plus 6x plus 2x plus 12. So if we collect like terms, it's going to be x squared plus 8x plus 12. So again, for the second one, first, outers, inners, last. So we're going to have x squared plus 7x, take 3x, take 21. So it's going to be x squared plus 4x, take 21. Okay, we've got these ones. These are of the type difference of two squares. So if we've got a plus b, a take b, and they expand to a squared take b squared. And that's all we have to do. And so these both fall under that category. So this is going to be x squared take 1 squared, which happens to be 1. This is going to be b squared take 2 squared. That's going to be b squared take 4. Question 3, expand the following. These are of the type perfect square. So if we have a perfect square, so we've got a plus b all squared, we square the first, square the last, double the product. Or if we have the type a take b all squared, we square the first, square the last, double the product. So for these two over here, we're going to square the first, square the last, double the product. So 2 times 5 is 10, so it's going to be 10x. So b, square the first, square the last, negative 2 times negative 2 is going to be positive 4, double the product. So 2 times 2 is 4, and that's going to be x. Expand the following. So this is trinomial expansion. So we're going to be looking at expanding. So basically similar to FOIL, except we've got an extra bit. So we're going to do the first term by everything in the second bracket, the second term by everything in the second bracket. So when we do that, we're going to get x cubed plus 3x squared plus 2x plus x squared plus 3x plus 2. So now we collect like terms, x cubed, so 3x squared plus x squared is going to be 4x squared. We've got 2x plus 3x, so it's going to be plus 5x, and we've got plus 2. So that is now expanded. When we've got this situation, we choose 2 brackets to expand, and then we choose the third one. I'm going to choose the second 2 brackets to expand initially. So on my second line, here, I'm going to have x plus 4, close the bracket, and then I'm going to expand the second 2. So I'm going to use FOIL, first, outers, inners, last. If you want to expand the first 2 first and then times it by the second one, it doesn't matter which way you do it. You can do the first and last and then times it by the middle one. Any one of those things will be fine. So first, that's going to give me x squared plus 2x plus 3x plus 6. Just to simplify that, x plus 4, haven't done anything with that yet, so we'll leave it as x plus 4. So it's going to be x squared plus 5x plus 6. So now we've got 2 brackets, so we do the first term by everything, and we do the second term by everything in the second bracket. So that's going to be x cubed plus 5x squared plus 6x plus 4x squared plus 20x plus 6 4s are 24. So it's going to be x cubed plus 5x squared plus 4x squared, so it's going to be 9x squared, plus 6x plus 20x is going to make it 26x plus 24. Question 5. Factorise the following. So we're doing factorisation. So we're going to use this little table over here. Let's make that a little bigger. So first of all, we need to look at it. Are there any common factors? Yes, there are. So this one here, we're going to take a common factor of 2 out, so x plus 1, and that's as far as we can do. Again, B here, take a common factor out. Yes, there is. So it's going to be, take a common factor of x, so it becomes 2x plus 1. And that's as far as I can go. So they're now factorised. Question 6, factorise the following. Is there any common factor? Yes, there is. There is this part here that are in each term. So I'm going to take that out as a common factor. So x plus 5. And the first term here, I'm left with a 3. Second term here, I'm left with an x. So that becomes now factorised. Factorise the following. So again, I'm just going to make this a little bit bigger so we can see it. Is there any common factors in this first one? No, there's not. Is it an a squared take b squared example? Well, there's definitely a take and it's 2 terms. So let's just check to make sure it is. So it's x squared take 2 squared. So yes, it is a difference of 2 squares. So we're going to have x take 2, x plus 2, or x plus 2, x take 2. And what we find is we go through the same process as that one. So it's going to be 2 squared take x squared, so equals x plus 2, x take 2. So that, they're both factorised. Sorry, not x plus 2, x take 2. It's going to be 2 plus x, 2 take x. Sorry about that, my mistake. Question 8. We'll go through these again and have a look. Is there a common factor? Yes, there is a common factor. So we take that common factor out, 3. So it's going to be x squared take 9. Then we look at what's inside those brackets there, and we find out it's a difference of 2 squares. So we'll leave the 3 out the front, and so it's going to be x plus 3, x take 3. And so that's now fully factorised. So we look at the next one here. Is there a common factor? Yes, there is. The common factor is -2. And we get x squared take 4. Is it a perfect square? Most definitely is. So I got -2. And so it's going to be x plus 4. Not 4. We've got to take the square root of 4, which is 2. And x take 2, because 2 squared is 4. So that's now fully factorised. Question 9. So let's have a look at question 9. Is there a common factor? No common factor. So now let's have a look. Is it a difference of 2 squares? There's 3 terms, so it's definitely not that. Is it a perfect square? Well, what I usually do for that is I look at the last term. That last number is a square number, so it's potentially that. 3 squared makes 9, so let's look at double 3. Double 3 makes 6, so therefore it is a perfect square. And so we can go x plus 3 all squared. Then again, we look at the next one. There's no common factors. It's not 2 terms, so it's not a difference of 2 squares. So let's have a look at this. 16, that's a square number, so I could write this as x squared plus 8x plus 4 squared. So it's definitely that one. And 8x happens to be, so I could write this as x squared plus 2 times 4x plus 4 squared. So it's definitely that one. So I can write that as x plus 4 all squared. With this, I don't expect you to write this bit here, this bit here not required, but it goes through my thinking process. Next one, fully factorise. So again, we look at our process. Is there any common factors? Well, there are some common factors here, because if I split my terms up into 2 groups, I can do some factorisation of these. So in this first one here, I can add a common factor out of x, so I get 3 plus y plus 3 plus y. And now I end up with this situation, which I still have a common factor of 3 plus y, and I'm left with x plus 1. And so that now is fully factorized. So sometimes it's common factor. You don't have to take the common factor out of the whole thing. We can split our terms up into individual bits. So again here, I'm going to do the taking out. So I'm going to split this up into 2 groups because I can take out some factors. The first one here, I'm going to take out a factor of 2, so a plus 1. And the second one here, I'm going to take a factor of b, so it becomes a plus 1. So here we've got a plus 1 plus, and we're left, whoopsie, not plus, sorry, my mistake, times by, and we've got left 2 plus b. And that's now fully factorized. Question 11. Fully factorize the following. Is there any common factors? No common factors. Is it a squared take b squared? No, it's not. It's not 2 terms. Is it a perfect square? No, that number there is not a square number, so it's not a perfect square. Is there a letter in front of the x squared? No, there's not. So it's got to be using this method here, which is the sum and product type. What does that mean? We need to go through all the factors of 2, which happens to be those, and which add up to 3. And so that one there becomes the correct one. And so our answer here is going to be equal to x plus 1, x plus 2. So for B, through a different colour, is there any common factors? No, it's not difference of 2 squares. It's not a perfect square. There's no a value, so it's that one again. So again, we go through the factors of 6. So 1 and 6, that makes 7. And -1 and -6, which makes -7. Then we can go 2 and 3, which makes 5. In fact, that's what we want, because up here we have to add them to something positive 5. So now we can write that as equal to x plus 2, x plus 3. And that is now fully factorized. That is the test done. Thank you for listening.